So let's continue with our free body diagrams. So let's read the statement and then we can formulate also the equation. And don't forget to subscribe if you find this so much helpful. So two blocks of masses 1.5 kgs and 3.2 kgs are connected by light inextensible string. So already we know that here there is tension and we know there is mass, so there's also Fg, and this is on a surface, so there's normal force as well. So a 24 Newton force is applied on the system of the blocks to move them up an inclined surface which is 25 degrees to the horizontal at a constant velocity. So when something is moving at a constant velocity, always remember that the acceleration is 0. So these are moving up and inclined. So the 1.5 kg block experiences a constant frictional force of 2 newtons. So there's also frictional force to this object. So if the objects are moving up, so it means that our frictional force will be moving in the opposite direction. Always remember that. So now let's draw our free body diagram of block B. So we started with block B in this situation. So let's see. So this is showing the object and perpendicular to the plane we have the normal force. So this will be our normal force, and Fg will always be acting straight downwards. So this is Fg, and then up the incline you can see that this is being pulled. So this is the tension on block B, and block B is also having the frictional force, right? So now let's try to formulate the equation of motion of this object, but before we do that, let's first talk about this Fg. So always remember that this Fg is acting at an angle, so it will have two components, which is the Fg perpendicular and the Fg parallel. So now let's see how many forces are acting parallel to the plane now. So we're having 1, 2, 3. They're acting parallel to the plane, and which is also parallel to the motion because these are moving up the incline. So what would be the equation of motion of this object now? We know that our F net is equal to ma, but our acceleration in this situation, it is 0, so our F net will be equal to 0. So what is our F net now? It is these three forces that are parallel to the motion. So this will be tension plus frictional force plus Fg parallel will be equivalent to 0. So this is a positive force since it is going with the motion, and these ones will be negative because they're moving opposite to motion. So this will be tension plus minus frictional force plus minus Fg parallel being equivalent to 0. So don't forget how to find Fg parallel. We said Fg parallel is equal to Fg sine of theta, and which Fg is equivalent to mass times gravitational acceleration, with the g is constant as 9.8 meters per square second. So always remember that. So this is our equation for the block B. So now let's move to block A. Let's see how we can formulate the equation from the free body diagram. So just because they told us that this object is experiencing frictional force, And these two objects are sitting on the same surface, so it means that this will also have frictional force. So at first we have normal force since this object is on a surface, and you're going to have frictional force, and you're going to have force applied. So we're having the force applied, which is 24 newtons, and you're also going to have Fg since this object is having mass. So it will have Fg as well as tension, because these objects are pulling each other up. So it means that there will be tension in the string. So how can we draw our free body diagram now? So this is object A. So object A, again, we are going to have our normal force, which is perpendicular to the surface. I'm sorry about this drawing. So this is our normal force, and you're going to have Fg, which is always perpendicular downwards. So this is our Fg, and you're going to have the force applied, which is parallel to the plane, and you're also having the tension, which is pulling this object, and you're also having the frictional force. So these are all the forces acting on the object. And also remember that this object, we have what? Since there's Fg that is acting at an angle, this Fg, we have the components like we talked about. It will have Fg perpendicular, and it will have Fg parallel. Always remember that. So how do we formulate our equation of motion now on this object? So if we take a look at this object, we can see that we are now having how many forces that are acting parallel to the plane now, or parallel to the motion. We're having 1, 2, 3, and 4 forces that are acting parallel to the motion. So now how can we formulate our equation now? So we know that F net is equal to mass by acceleration, and in this situation our acceleration is 0. So since our acceleration is 0, now let's deal with these forces now. So this is the only force that is going in the positive direction, because this is going with the motion, and these 3 other forces, they are working against the motion, so they will be negative. So now we're going to have force applied plus tension plus frictional force plus Fg parallel is equals to 0. So now putting or taking account of the direction, our force applied is positive, plus our tension, which is negative, plus our frictional force, which is negative, plus our Fg parallel, which is also negative. So this must be equivalent to 0, since these objects are moving at constant velocity. I explained that on our lessons, that constant velocity means that the acceleration is 0. Why is the acceleration 0? Because you know that acceleration, it is Vf minus V initial divided by time. So now if this is not changing, if maybe the velocity is remaining as 5, so if we say 5 minus 5, we get 0. So this will be 0 over time. So any number dividing into 0, we get 0. So that's why our acceleration is 0 when we are having constant velocity. I hope you gained something from watching this video. If you have, please show us by liking this video and also subscribing to our channel. Have a lovely day and keep on checking to learn more with us.